the first hints of artificial origin emerge not through dramatic technological revelations, but in subtle structural anomalies that distinguish 3I Atlas from typical natural objects formed through conventional astrophysical processes. Density measurements reveal internal architecture that appears too organized, too precisely stratified to result from random accretion or gravitational sorting, suggesting engineered mass distribution designed to optimize structural integrity during millions of years of interstellar acceleration and cosmic ray bombardment. High-resolution imaging reveals surface features with geometric regularities that exceed the statistical expectations for natural weathering and impact processes, including linear formations, angular boundaries, and symmetrical structures that could theoretically represent manufactured components or technological systems concealed beneath layers of cosmic dust and radiation, processed surface materials that accumulated during prolonged interstellar exposure. Spectroscopic analysis detects trace element distributions that violate natural abundance patterns expected for objects formed through stellar nucleosynthesis and planetary accretion processes. With systematic enrichments in rare Earth elements and isotopic ratios that suggest artificial concentration and purification processes that operated according to technological rather than astrophysical principles during the object's formation, thermal emission patterns exhibit systematic variations that could indicate internal heat sources or energy distribution systems operating according to engineered rather than natural thermal transport mechanisms, with temperature gradients that suggest directed energy flow through designed pathways rather than simple thermal conduction through homogeneous materials that characterize natural cosmic objects. Rotational dynamics reveal anomalous characteristics, including non-principal axis rotation and complex tumbling behaviors that could theoretically result from a symmetric mass distribution designed to optimize orientation control and communication system pointing during interstellar cruise phases, creating rotational signatures that distinguish artificial from natural objects through engineered rather than chaotic dynamical evolution. Only took advanced observational techniques a few decades to achieve sensitivity sufficient for detecting subtle artificial signatures that might distinguish manufactured objects from natural cosmic bodies. Yet such technological artifacts could theoretically remain unrecognized for centuries without systematic analysis, designed specifically to identify engineering signatures rather than conventional astrophysical characteristics. Material property analysis reveals mechanical strength characteristics that exceed theoretical expectations for natural cosmic materials subjected to millions of years of thermal cycling and radiation damage, suggesting composite structures or engineered materials designed to maintain structural integrity under extreme environmental conditions that would destroy conventional natural assemblages over geological timescales. Electromagnetic signatures include systematic variations in radio frequency emissions and reflection characteristics that could theoretically represent engineered electromagnetic properties designed for communication, navigation, or stealth applications rather than natural electromagnetic responses that reflect simple material composition and surface texture characteristics. Chemical stability indicators suggest resistance to space weathering and cosmic ray degradation that exceeds natural material capabilities, potentially indicating engineered surface treatments or protective systems designed to preserve functionality during prolonged interstellar exposure to radiation fields and micrometeorite bombardment that would alter natural surface composition over cosmic timescales. The mystery of observational subtlety emerges from recognition that advanced technological artifacts might be designed to appear natural to primitive observation techniques, while concealing artificial characteristics that become apparent only through sophisticated analysis methods that exceed the technological capabilities of species in early stages of astronomical development. Comparative analysis with known natural objects reveals systematic deviations in multiple observable characteristics that collectively create statistical signatures inconsistent with natural formation processes, yet individually remaining within ranges that could be attributed to normal variation in cosmic object properties without comprehensive multivariate analysis designed to identify artificial origins. Structural coherence measurements indicate internal organization that maintains geometric relationships and material distributions despite millions of years of thermal cycling and mechanical stress, suggesting engineered designs that account for long-term structural evolution under interstellar conditions rather than natural accretion that creates randomly organized internal architecture. Surface modification patterns exhibit systematic characteristics that could theoretically represent controlled ablation or engineered erosion designed to reveal internal systems or modify external appearance according to predetermined schedules rather than random space weathering that creates unpredictable surface evolution over cosmic timescales. Information theoretical analysis of structural and compositional patterns reveals organizational complexity that exceeds expectations for natural processes while approaching levels that could theoretically encode information through systematic arrangements of materials, isotopic compositions, or structural configurations that preserve data through physical rather than electronic storage mechanisms. Statistical anomaly detection algorithms identify correlations between multiple observable characteristics that create signatures inconsistent with natural formation scenarios, yet potentially explicable through artificial origin, hypotheses involving deliberate engineering design that optimizes multiple functional requirements simultaneously through integrated technological solutions. Future analysis techniques will employ increasingly sophisticated pattern recognition and anomaly detection methods to identify artificial signatures that might distinguish technological artifacts from natural cosmic objects, while developing new theoretical frameworks for recognizing engineering characteristics that operate according to design principles potentially unknown to human technological experience. The implications of potential artificial origin extend beyond scientific curiosity to encompass fundamental questions about technological evolution, cosmic civilization development, and the possibility that interstellar space contains archaeological artifacts from extinct extraterrestrial intelligence that achieved technological capabilities exceeding current human spaceflight technology before disappearing from the cosmic stage millions of years ago.